Here we have a SAT math problem. Okay, let's go to the question. Here we have a system of two linear equations. In the system of equations above, P and Q are constants. If the system has infinitely many solutions, what is the value of P positive Q? Okay, before we start solving this question, let's consider a system of two linear equations in standard form. That is A1x positive, B1y equals to C1, and A2x positive, B2y equals to C2. Okay, here we have a system of two linear equations in standard form. Standard form means we'll have the x term and y term on the left side of the equation and a constant on the right side of the equation. Okay, here let me find the ratio of the coefficients of x. Then we get a1 over a2, and also the ratio of the coefficients of y, that is b1 over b2, the ratio of the constant terms are c1 over c2. Okay, if a system of two linear equations in standard form has infinitely many solutions, then the ratio of the coefficients of x, the ratio of the coefficients of y, and the ratio of the constant terms must be equal. Okay, here when I consider the given system, both the equations are not in standard form. Here we have x term and y term in the first equation on the left side, and on the right side we have y term. So to get the first equation in standard form, we have to get rid of this y term. Okay, now let me do this one over here. Let me write the first equation, that is px negative 5 over 3 times y equals to 1 over 3 times y positive 12. Okay, to get rid of this 1 over 3 times y, let me subtract a 1/3 y from both sides. Okay, let me do it. When I do so, this positive term, negative term will cancel. Then I'm getting px negative 5 over 3 times y can be written as 5y over 3 negative 1/3 y can be written as just negative y over 3 equals to 12. Okay, here we subtract two fractions with the same denominator. Okay, now what we can do is we can take this 3 as a common denominator. Then we have to simplify the numerators. That is negative 5y negative y over 3 equals to 12. Okay, let me continue over here. Px, okay, here when I combine negative 5y and negative y, I am getting negative 6y divided by 3 equals to 12. Here 3 goes into 3 one time, 3 goes into 6 two times. I am getting px negative 2y equals to 12. Okay, here I got the first equation in standard form. That is we have x term and y term on the left side. On the right side we have constant. Okay, let me write the standard form of the first equation. That is px negative 2y equals to 12. Now let me do the same thing for the second equation, that is getting this equation standard form. For that we have to get rid of this 1 over 2 times x on the right side. Okay, let me do it over here. That is 7 over 2 times x negative qy equals to 1 over 2 times x positive 6. Okay, let me subtract 1 over 2 times x from both sides. When I do so, this positive term negative will cancel out. I am getting 7x over 2 here, and this one can be written as a negative x over 2 because 1 times x is x, that is negative x over 2, negative qy equals to 6. Okay, here we subtract two fractions with the same denominator too, so we can take this 2 as a common denominator. Then we get 7x negative x over 2 negative qy equals to 6. Then we get 7x negative x is 6x, that is 6x over 2 negative qy equals to 6. 2 goes into 2 one times and 2 goes into 6 3 times. I am getting 3x negative qy equals to 6. Okay, now I got the second equation in standard form, that is 3x negative qy equals to 6. Okay, now let me erase the stuff over here and continue the problem. Now we got both the equations in the given system in standard form. Okay, here in the standard form, we can apply the stuff what we have already discussed because the given system has infinitely many solutions. In that case, in the system of two linear equations standard form, the ratio of the coefficients of x and the ratio of the coefficients of y and the ratio of the constant terms, all the three ratios must be equal. Okay, first let me get the ratio of the coefficients of x over here. That is p over 3. Okay, the ratio of the coefficients of y is negative 2 over negative q. The ratio of the constant terms is 12 over 6. Okay, we can write the first ratio as it is. Here this negative will cancel out. We get 2 over q, and 12 over 6 equals to just 2. Okay, here three quantities are equal. If three quantities are equal, any two out of the three quantities can be equated. Okay, now let me equate the first and the third quantity. Then I am getting p over 3 equals to 2. Okay, now let me multiply both sides of this equation by 3. Then this 3 will cancel out. Then p equals to 2 times 3 is 6. Okay, now I got the value of p when I equate the first and third quantities. Now let me equate the second and the third quantities. That is 2 over q equals to 2. Okay, now let me take reciprocal on both sides. When I take reciprocal for this 2 over q, I am getting q over 2, and when I take reciprocal for this 2, I am getting 1 over 2. Okay, now let me multiply both sides of the equation by 2. When I do so, this 2 will cancel out. Here 2 will cancel out. I am getting q equals to 1. Okay, now I got the value of p, that is 6, and I got the value of q, that is 1. According to the question, we have to find the value of p positive q, that is p positive q equals to, so we know that p equals to 6, so we can plug in 6 for p, and for q we know that 1, we can plug in 1 for q, p positive q equals to 7. Okay, here I got the value of the expression p positive q, its value is 7.